The construction of the KV33 from the company GIS was a demanding project that was carried out by an experienced team. Work began with the construction of the improved model according to the instructions provided by the American company Async from California. The financing of the project was completely taken over by this company. The original place where the machine was built was a former mine that was shut down in 1987. The company GIS had bought the cave systems and mine shafts and set up a research laboratory above them. The old mine shaft was completely filled with cables and pipes to allow the KV33 to be built. The instructions for building the KV33 have been carefully checked and any issues should be resolved by the GIS company. The guide also included detailed information on how to avoid earthquakes and interdimensional bubbles. Despite this, interdimensional bubbles could still occur, albeit in smaller amounts than expected. The KV33 was equipped with extra magnet units, which should prevent the interdimensional change of the wavelength outside the portal. The improved model was built by the GIS company to the instructions of the Async company and all funding was provided by that company. The GIS company built the KV33 for a specific purpose that remains anonymous in this report. The project was carefully planned and executed to ensure the safety of everyone involved. Michael Deutz wrote this report to document the details of the project. Building the KV33 was a technically demanding project undertaken by an experienced team to achieve a goal not detailed in this report. In addition to my previous report, I would now like to report on how the new KV33 machine from GIS works. The new machine was equipped with 6 Commodore VIC-20 computers, 3 of which are responsible for the even transfer and distribution of energy. The other 3 computers are specially designed to keep the magnetic confinement barriers stable. The 3 computers responsible for power distribution are programmed to that they can distribute the energy evenly to all components of the machine. This balanced energy distribution ensures an optimal and effective function of the machine guaranteed. The other 3 computers, on the other hand, have an important job in maintaining the magnetic confinement barriers. These barriers are needed to prevent interdimensional wavelength shifting outside of the portal. Continuous monitoring and adjustment of the barriers ensure stable operation of the machine. To ensure that the machine works optimally, an extensive test phase was carried out in which all components were checked for their performance. The results of these tests were very promising, since the machine showed high efficiency and interdimensional bubbles appeared only in very small amounts. In conclusion, I can say that the new KV33 machine from GIS has impressive performance and will play an important role in R&D with its improved technology.